Thank you very much, Yuri. Thanks, Steve, for giving me this opportunity to talk to people about science of performance. Sri gave a very like amazing presentation about different tools and connection with actually performance. And I think the slide that was catchy for me is the developers' roles. He was talking about programmer, software architect, and performance engineer. And in my presentation, I will be mostly about science of performance, which means mostly I'm going to talk about performance engineer. So I'm Dr. Murad Bouash. I work at the Verizon Media and Performance Engineering Group. If people from my team they're watching this presentation, I say hi, and I know that some of them they are working from home, like everyone, especially for the Corona or COVID-19. So my presentation is going to be about the performance engineering, and this is what my team is doing. So we work mostly about hardware review, hardware request evaluation, research and development, everything which is connected to the next generation technology and TCO model, where we understand what's the performance and price and try to find the best way or trade-off between these two, I would say, metrics. We have a hardware lab where we do all our tests, where we do performance benchmarking and the performance simulation. All these keywords, I'm going to explain what does it mean. And of course, when we work with the performance, there are a lot of data. So we do a lot of data mining, analysis, and also finding patterns. Of course, now with artificial intelligence, machine learning, and deep learning, we are trying to connect between artificial intelligence and performance engineering. So I'm going to talk about all these things through the agenda for performance, benchmarking, and profiling, hardware and software, different components on the server, CPU, memory, I/O, GPU, FPGA, different compute or intensive compute resources, cloud performance. We cannot talk about performance without the cloud, and artificial intelligence and performance engineering. How we can work together to solve performance issues and bottlenecks. I think the idea is also to talk about the career, performance career. I did this presentation also in Stanford for the summer seminar because most of the students, they didn't know what does in performance, and they didn't know actually what does it mean performance career. For them, it's software engineer, programmer, and they don't know that there is a career, there is a profession for performance. When I finished my PhD, so I have a lot of background in research, especially with performance. So I did a lot of performance research through my PhD and postdoc, different postdocs that I did in France, Illinois, and Waterloo, Canada. Some are in a classic system or traditional system, and some of them they are in embedded system, where I try to find bottlenecks, issues through the performance research. Performance research mostly is about software. I used a lot of software tools, libraries. I didn't have access to the hardware because maybe the labs and research, we don't have enough money to play a lot with hardware. We have limited access to the hardware. When I moved to the industry through Yahoo and Oath and Verizon, with all the data centers that we have, I had more access to the hardware. So I learned a lot in the industry about hardware, because mostly we touch the hardware, we test things, and thanks to our managers, especially Hugo, he gave us like a green light to do whatever we want, especially project that we have in any initiative, to play with the hardware and try to apply the software tools and libraries to get the performance. So I think the mix between this research and the industry is very good interaction between actually the software and hardware in terms of performance. These are the books that I used when I was preparing my PhD and even before during my master. Architecture des ordinateurs. It was in 2003. It's the French version. So and it's actually the English version. It's a computer architecture from John Hennessy and David Peterson. And I know that a lot of you guys you know about these two people, that they are a reference for me in terms of architecture or background in computer architecture or microarchitecture. I had the honor to meet actually David Peterson from University of Berkeley in Facebook at Scale in 2018, and he gave an amazing presentation about what was before, now, and in the future about the computer architecture and the CPUs in general in terms of architecture and the usage of the CPU in the future, especially with this artificial intelligence and the machine learning and deep learning. John Hennessy, who is the former president of Stanford University, I also met him through his he signed a book that I bought, his book Leading Matters, and believe me, this book is amazing in terms of leadership, and it was in 2019. So I met him in person as well, and you cannot believe, as a student I was in France, and then when I came here, I was reading about his what he wrote in his book, and then meeting him in person is kind of inspirational, or gave me a huge motivation, especially in my field. So where is performance? Everyone is talking about performance, but we physically we don't know. We have some kind of abstraction about the performance. And this is actually a good illustration of our data center at Yahoo. And then if we are talking about performance, it's everywhere. So the sign of performance in the orange sign, we can see it everywhere, even at the user. The only thing that we cannot control is the user computer and his network as well. But the rest is everything we can do it with the application that we have, the software development, the data center, the cloud, the grid, which we call the grid at the company, and all the data highway, or the connectivity between all the servers and data centers through the network, and also the servers that are running. So performance is everywhere, and if we zoom a little bit on the application, it's also the performance is through the application, because most of the people, especially developers, I don't want to make enemies today, but people, they think about functionalities and deadlines, but they don't think about security and performance. So I think these forums and conferences, I think they will give a good exposure about like software performance is connected to software development. It's part of the life cycle of performance. So performance study tell us about why is some hardware better than others, for example, and the different programs as well. What the factor of system performance are hardware related or different thing. And every time when we have this issue or bottlenecks in performance, people, they think the first is the hardware, and then when we talk to them, and then we see the mix about this interaction. So the interaction between software and hardware, this is also a definition of the performance. And we can go even deeper about the instruction, the microarchitecture that Intel is a hardware company that developing all the CPUs. It's also part, they are doing also a lot of performance analysis to get the best CPU for our data centers. So our mission at the Performance Engineering Group at Verizon Media is, when we have a performance issue, the first step is going to be reporting to us. So let's say we have a team or service, they are facing a problem with performance, they report to us, they send us an email, or all the tickets system, environment, ecosystem that we have. And then the first thing is we determine if it's a hardware or software issue. And the two parts are different, but the meeting point, there's only one meeting point. Maybe the process also similar when it comes to the software issue and hardware issue. It's all about exploration, it's all about analysis. But for software, it's actually, I think, through all the experience that I have, I think software issues are more complicated because they are more dynamic. Plus, there's more communication that we need to set or to create this channel between the performance engineering or a group or a performance engineer and the software engineer, where we need to do code analysis, code profiling, and the code profiling is going to be through different tools. But communication is the best tool, I would say. Communication, which means to ask a lot of questions to develop, because any question is not going to hurt. So we can cover everything, and I think this is the way how we can solve the problem, especially when we have some emergency to solve. It's not only about just jumping on the code analysis or code profiling. In the hardware side, the idea is to reproduce the issue and try different solutions, or replacing actually the hardware itself. And the meeting point is going to be finding this, either if it's software or hardware, it's going to be a solution, and then we validate this in production host, for example, and then we are going just to roll out to all affected production hosts. But the best thing is actually creating this methodology, because every time we are going to face the same problem, we are going just to use the same methodology to solve the problem. Performance in real life, it's kind of, I know that you miss, every one of you miss traveling. I don't know, maybe for 3 or 4 months we didn't travel, we didn't go to the airport. I know that you missed these pictures of the of the airplanes. Yeah, performance is, I don't want to give, usually I use Air France to go to visit my family, but it depends. Of course, we don't see it in your perspective, which airplane you are going to take to go to visit or go for vacation, but take it in a perspective of the if you are Air France or you are for American Airlines, how you are going to select which airplane or aircraft are you going to use for any specific trip. We are talking about Boeing 777, 747, DC-850, and Concorde. So even more than that, which airplane you are going to buy for a specific trip or set of trips or travels. If you go with the different planes here, you have the different characteristics between speed, range, passenger, and time, and we can use throughput here as part of the metrics that we use usually in performance, but we can connect it with the real life. So these are the planes, these are the characteristics of each plane. So this is in perspective of airplane airplane company or airplanes company. You need to decide which one you need to buy. It depends depending on what you want to do. So performance is actually what you want to achieve. If you want to go with the speed, the Concorde is the best. If you want to go with a long flight, then you take the DC-850. If you want to mix between capacity and throughput, then it's going to be a mix or a multiplication between the passengers and speed. So in one given criteria, we can perform better than other criteria. So performance is kind of really relative word that it depends of what we are looking for. So we have two aspects in performance, which we call latency and throughput. So latency is the response time or by the execution time, or how long does it take to execute a job, a thread, whatever you call it. In database, we call it query. A throughput is a task per unit of time. So the definition is very important because this will help you understanding what you are looking for and what you want to achieve. Performance definition, if we are talking about my background, which is in microarchitecture or CPU design, performance is in unit of things second. Better is better, bigger is better. And if we are primarily concerned with the response time, then the performance is going to be one upon execution time. And the execution time it can be a number of instructions, by CPU or cycle per instruction, and then you multiply it by the time of the cycle. If you would like to increase the execution time, then you need to increase all this number of instructions, CPI and cycle. If you want to increase the performance, then you need to decrease or reduce all these things. And reducing the number of instructions can be with a compiler, for example. And one hint is for the Intel product is the Intel compiler or ICC. CPI is mostly about the microarchitecture that we have every time through TIC and TOC, and I think now the Intel changed it a little bit, and also the time or the cycle. So increasing the performance is going to be by reducing the execution time if we are talking about the CPU architecture or microarchitecture. In the performance of computers, we use this spec, and everyone knows about it. And this is the language between us as a performance engineering group at Verizon Media with Intel. The number or the score, we call it the score also, is the language when we talk about the new generation of the CPU, where we do a lot of benchmarking or measuring, evaluating the performance of a function, operation, or a business relative to others. Of course, the hardware performance, we are talking about the CPU, memory, and network, or IO and IO or disk. And if we talk about the CPU, this is the TikTok that I was talking about, starting in the Helm with the 45 nanometers, and then now with the Cascade Lake staying with the 14 nanometers. So this is the innovation that for the new microarchitecture with Skylake, and then now Cascade Lake go into the new generation of Ice Lake CPUs. Staying with the CPU, a CPU frequency is part of the performance, and then you can see this is a beautiful a chart or graph from this publication. I need to keep the reference original data up to the 2010, but collected for 2020, and this is the last year of this graph, and then you can see the number of logical cores, typical power, frequency, single thread. Some of the typical, I think for the number of logical cores, we are a little bit more than what we have in this graph, especially with Cascade Lake. We have a single thread performance, spec INT multiplied by 1000, and transistor by thousands here. And we can see the transistor going exponential with different other characteristics in terms of frequency and number of cores. This is one of the performance certification that we do, and what you can see here is actually the power per watt, and then running spec 2000 precompiled the first stage, and then native in second stage, and then waiting a little bit to build and the spec 2006. I can do the same thing with the spec 2017, but you can see in terms of changing the memory from 32 gig, 48 gig, and 64 gig, you see the performance in terms of watt or measuring the power in a E5 2670. I think it's Sunny Bridge here, or Ivy Bridge actually. V2 is Ivy Bridge. The hardware certification process, what we do when we have a new CPU, for example, we do the benchmark, the spec 2000, 2006, and 17. And then after this, next step is going to be power analysis, or it can be the same way, like the previous graph I gave or I presented. And then memory configuration, which is very connected to the CPU. And then also you have this BIOS settings that we need to set them before any configuration or any benchmarking. Server components, this is what, if we are talking about performance, we need to talk about the CPU, network, power, disk IO, memory, and also other compute resources in terms of GPUs, FPGA, anything else, ASIC, whatever we would like to do is going to be through this. If we talk about the CPU performance, the compiler it has huge impact in performance score if we are doing benchmarking. So performance for range of workload, the BIOS is also important, and then also the memory, it has some impact on the CPU performance if we are talking about the benchmarking or the benchmark score. This is one of the specification or characteristic of the Skylake CPU, where you have the CPU TDP in watt and in the socket, if it's going to be single, dual, or whatever number of socket that we have, and cores up to 28 core with Intel hyper-threading technology, and you have the memory, and then you have the PCI and the number of channels in terms of memory population. So the memory performance is also one of the big chunk in terms of performance, where it's limited resource available to the application, and poor use of this resource can affect really the performance. The DIMM speed, the DIMM speed is also has also a huge impact. So every time we take a component, we go deeper, and then you can see that it can affect performance. For example, memory, one of the examples, the memory leak, and then more object is going to be kind of part of the bad programming instead of art of programming. If we are talking, for example, here of a Java application where you do allocation for objects. Memory efficiency, when we create object, you see something like this, and you are eating more and more of your memory, and this will have impact on your performance. We would like to be stable instead of being increasing all the time in terms of memory, which affect the memory efficiency. And one of the things that we use for this is the memory analysis through the VTune, where we do memory access, which is very, very helpful in understanding what's happening in a memory when we are running specific application or workload. Memory population is important, so accurate memory population will have good impact on performance. Of course, if we are not doing a great job in population, then it's going to affect our performance. Using the memory DDR as well, DDR1, 2, 3, by 2020, the DDR5, and the frequency or the data rates coming with is also affecting the performance as well. I/O performance, minimizing the disk reads and write, is going to help a lot in performance, and then you can see different tools that you can get through the disk. For us, we for everything which is I/O, it's actually we have specific tools internally that we are using to check the performance of I/O, and just say hi to Samir, who is taking care of this. I/O performance for hard disk and SSD, why we're using SSD. All these things are very helpful in extending the performance of the I/O. I don't want to go deeper on different things here, just want to talk about the performance as a science and going through different components of the on the server and network. Minimize the network latency is going to help a lot in terms of network efficiency or performance, and trying to avoid latency through the network. Network performance, here we have a new generation of the 10 gig or 25 or 100 gig between latency and throughput, and then we can go with even FPGA, using it for as a card for networking application, especially with the live video streaming and all this crazy things are coming with the extended reality, virtual reality, and augmented reality, and also with the 5G application for smart city or different other big application using 5G and artificial intelligence. Of course, we care about performance for accelerator, GPU, and FPGA, and the impact that if we are talking about different deep learning applications. These are the deep learning applications or artificial intelligence projects we have at Yahoo and Verizon Media that we are using either the GPUs or FPGAs to help with the training or inference, the two big operations that we use. Parallel processing and also inference, we are using Intel CPU with the FPGA that they are offering too. Waiting for specific GPU for neural network training and inference. If we talk about software performance, mostly it's going to be about monitoring, benchmarking versus profiling, and there's a lot of confusion between what does it mean benchmarking versus profiling, and what are the profiling tools. Real issue that I'm going to expose here, that we used Intel VTune with the help of Intel. We solved a lot of big problem, and we saved money, and we helped on generating revenues through solving this problem. And I'm going to talk a little bit about different performance tools. Of course, when we talk about software, it's all about actually, yeah, it's going to be all about the algorithm efficiency, and everyone knows about this graph where we have exponential complexity and then big O of n as measurements for this complexity, and everyone is looking for this O of 1 as the best complexity of software algorithm. Monitoring, profiling, and benchmarking. So the benchmarking or profiling, that's just for a definition. Benchmarking, keep it in your mind that benchmarking is mostly about evaluating, and profiling doesn't compare multiple versions of the same operation function. It just tells us what are the slowest part of the code. This is why VTune is a profiler or profiling tool, and not benchmarking, where we use workloads like Spec 2017 to compare between CPUs, for example, performance. So it's more about finding and eliminating waste and wait time, and find areas to tune and extending the system limit. All these things, these are the profiling actually actions that we can use. And if we take the whole system between user mode and kernel mode, we have different layers of application, operating system call, interface, TCP, scheduler, virtual memory, to device and drive. Of course, we are starting from the bottom to up, CPU, which is the hardware, DRAM, I/O, and disk and network. Every level has specific tool that we use. VTune can collaborate, or it can be the tool that we use, and on the application side, and also to understand what's happening on the CPU, or why the application or a specific function is spending most of the time on the CPU. I gave a presentation at Stanford last year. In 9 months, I got 3,000 views. You can go through Intel VTune Amplifier or this link and check the video if you would like more details about the Intel VTune, and also Intel is giving amazing documentation for Intel VTune amplifier, and one of the presentation that Sri is gave today is also amazing presentation if you need to know more about Intel VTune amplifier. This is one of the problem solving that saved a lot money and also time, where we started from an issue of a QPS of 270, and through the VTune profiling with the tuning and code improvement or modification, we could get almost x or 10x, 10 times the performance that we get at the beginning with a stable latency. Where we had a lot of issues with NUMA issues, garbage collection profiling, latency between servers, and memory profiling or memory heap, where we use different functionality that VTune is offering, especially with the Java applications for garbage collection, for memory access, and so on. So it's really it was very helpful in the key to succeed in this project. Yeah, this table is just to give you what you should use in term of if you have a more application focus in one application running or system focus, where you have the whole thing kind of a general expression of your system between small tools, which is very good methodology. We don't need to jump in Intel VTune, for example, right away. Some small tools to understand what's the problem before to jump on it. We have Intel Storage Snapshot, for example, for a quick performance analysis, or you can use Intel VTune for logs and weight, for example, analysis, Intel Platform Profiler for in-depth advanced collection of data and trying to find the bottlenecks. Scale out the performance, you have the challenges like scale horizontally or vertically to increase the throughput. And then also we are connected always with the cost. This is why we do the TCO model to drive the company capacity planning in terms of how many servers, plan the largest server and data center capacity or data center expansion plan, for example. Cloud performance, of course, everyone is using the cloud either for specific application, like for us, seasonal capacity change for fantasy sport. It's the best example where we use where the application is actually has a high CPU utilization only during the football season, where we use the virtualized compute network and storage resources, either private, public, or we do the hybrid, which is combination between the two workloads. Virtualization between VMs and containers, same thing. We use both virtualization and containers, and of course, we cannot talk about this without performance. And these are the values we would like to speed and maturity or security, and these are the solution, and the mix of them is actually the ideal solution and there is actually the VTune for containers and VMs. It's very helpful in terms of performance profiling as well. Storage performance snapshot, I talked about this, and they give you very good overview about the CPU and the system in terms of CPU, memory, and network, and disk as well, the I/O. Very helpful. I think I already have been talking about this too. And then the combination between performance engineering, artificial intelligence. We had this great project with Intel for a smart anomaly detection, where we use artificial intelligence deep learning platform to get our data, monitor data through our data centers and use artificial intelligence. And actually, it was very good mix between both worlds to solve the problem. For mobile performance, we use also one of the beautiful tools that Intel is offering, and now it's part of the Intel System Studio for Android application, where we use it in the past in Tumblr and Flickr to check the energy or power and performance. If you have any questions about performance, please connect with me in LinkedIn. I can help with things that I know, and thank you very much.
Thank you very much, Murad. We're open for questions. Asaf, if you or Steve have any questions, we can start that. If not,
There are two questions for Murad. The first one is if you can comment about the work that you're doing. Is that in the context of entire in Verizon or just the oath part of Verizon?
Yeah, so yeah, I think this is a good question. So the performance engineering group, it's a centric group, so we support and help everyone at the company. Of course, we have some performance engineering everywhere for part of Verizon, but we communicate with them and we help them, we support them as well. And we have which we call the embedded developers or software engineers and different teams and services where we connect with them to in terms of performance issues and we talk to them. If there is an emergency, it's a little bit hard to communicate with the developers. So this is why we have some people who are good in performance and also in programming that we can communicate with them and get the information very quickly. Yep.
Thank you. The next question is, in your experience, to increase CPU performance, how do you make the decision between more cores versus higher frequency?
Yeah, actually, of course, when we do benchmarking, I think that's the short answer is benchmarking. But in real application, real world application, when it comes to production, it's a completely different story. So I think we need to do benchmarking with the standard benchmark, which is Spec 2017, and understand which option we need to choose, either with a higher core count or the frequency, or in the real world, we need to actually test it and benchmark a real application in production and understand what's the best fit or best hardware configuration for a specific application. So I think the solution is going to be benchmarking, and this is the definition of benchmarking, is understanding which hardware configuration is the best, not only for CPU, but for different component of the server.
Thank you. Yuri, how much time do we have for Q&A?
Oh, sorry. We have a good 7 minutes.
Okay, so I'll keep asking. Great,
Yep.
questions are coming. So the next question, Murad, you mentioned that you're using many tools for many different scenarios, right? So how would you compare VTune, for example, with Perf or flame graphs for CPU profiling, and which tools would you recommend for which scenario?
VTune, of course. Yeah, I think this is a very good question, but there is a methodology for me. So the performance engineering group, we created the methodology that we start with the easy tools that can give us the information very quickly instead of jumping to the VTune. VTune is a little bit heavy, exactly like Perf. It depends. If for Perf and VTune, it's kind of a little bit advanced tools, but we need to start with SAR, TOP, all these small tools that give a little bit general exploration about your system, and then we go to intermediate tools where we understand where is the issue. Is it about the CPU? Is it about the memory? Is it about something else? Then we use specific tools for that. VTune and Perf will be the last section. Now between VTune and Perf, I think the visibility, the data analysis, the beautiful graphs, and which will be very helpful for developers and also for performance engineers. VTune is the best. The Perf is open source. Of course, it's helpful, and most of our entry level or students coming from university, they know Perf because it's free. So they come with this idea every time they need to do performance, they need to run Perf. But every time we tell them about VTune and how give them access to VTune and train them with VTune, I think with the time it's going to be more about habit using VTune because of all the data that we have, and also the way exposing the data and also analyzing the data. Very helpful for any performance engineer or even any developers. Yeah, it's good to make decisions. It's very helpful in terms of fast time to decision, I think.
Thank you. And yeah, for the audience, if you have additional questions.
I want to clarify that even though it seems like a paid advertise for VTune, it is not. Murad is one of the users. We do have relationships with many companies that use our products. We have technical consulting engineers in our team that work with the companies to help them solve problems. They do that for some of the accounts. So this is a mutually advantageous relationship between Verizon in this case and Intel, where where we provide great tools. They use it. They provide great examples on how the uses are successful, and they sometimes have feedback in things that they want to improve, and we use that feedback to make the product better. So thanks for your support, Murad, and we can continue with the questions now. Just wanted to.
Yeah, I'm not talking about the I'm not talking as a Verizon employee. I'm talking about myself as what VTune is, how VTune is helpful for me. Yeah, and as you explained very well, Yuri, it's not a paid advertising. It's just I think VTune for me is like everyday habit. Every day I need to run the things using VTune and explore performance using VTune because it is really, really helpful.
Thank you.
We don't have any additional questions at the moment. So last chance to submit questions while we still have Murad with us.
Yeah, we have about 3 minutes we can use.
Yeah, I see a question here. Nice presentation. Is there more detail on the machine learning work with the VTune results? We didn't use data from VTune to work with the machine learning. We have been working with the Intel in different style or different thing. So we didn't use the data coming from VTune. We have our ecosystem. We have our data monitoring system that that generating data, and then we use this data for specifically the machine learning work that we did is mostly about the CPU utilization and memory efficiency using our data with our monitoring system. Just clarifying.
There's another question here for you, Murad, about a tool called TopLev, coming from Intel's
NVLink TopLev before using VTune. No, I don't know this tool, TopLev. No.
Okay, great. Well, thank you very much.